Okay, so proceeding to example number 6. Okay. Again, usually this example number 6 talks about the scales of temperature, no? So, sabi dito, hot air balloons, no? From our example number 1, hot air balloons become buoyant. When you say buoyant is yun yung condition na biglang lumulutang yung isang object without any force, no? Without any external force. Okay, so yun yung tinatawag na buoyant. Okay, when the gas inside is heated with the burner below the balloon. Recall from example number 1 that at STP, a typical balloon contained 2.83 times 10 to the power of 3 kg of air. Just recall this one kasi nasolve natin to siya sa example number 1 na. So, if the temperature of the gas is increased to 50 degrees Celsius at a constant pressure, what is the mass of the gas that remains in the balloon? And the other question is, what mass can be lifted by the balloon? Okay, so yun. Now, we have here steps, okay? So, for step number 1, we have convert 50 degrees Celsius into absolute temperature Kelvin, okay? Yun yung pinaka first step daw. So sabi dito, you have to convert degrees Celsius into absolute temperature na Kelvin. Okay, so take note that this equation is also stated on your manual, no? So this equation also is derived from the assumption that meron tayong reference point in which yung tinatawag natin na standard temperature point or yung tinatawag nila na triple point of water. Okay, so na-derive din to siya using that one. We have temperature is equals to temperature in Kelvin plus 273 Kelvin. So the result is wait. Temperature in Kelvin is equals to temperature in degrees Celsius plus 273 Kelvin. Kasi the original equation here from your manual is temperature degrees at degrees Celsius temperature is equals to absolute temperature minus 273.15 Kelvin. Ito yung pinaka-original, but since ito yung hinahanap natin, yung absolute temperature in Kelvin, okay, so gawin mo is i-transpose mo yung 273.15 dito sa kabilang side, so makukuha mo na yung unit, okay, or yung Kelvin. Kasi yung Kelvin is yan yung gagamitin natin for us to be able to find the value of mass, okay, not the degree Celsius. Take note ha, throughout our discussion, okay, lahat ng ginamit natin na units ng temperature is in Kelvin. Take note of that. Okay? Wag na wag din yung gamitin si degree Celsius. Okay? Ibig sabihin nito, always ginagamit sa solving or yung mga assumption is the absolute temperature, not the degree Celsius scale. Okay? So yun. So just reminding you. Okay? So step number 2. Find the mass at T is equals to 50 degrees Celsius. Okay, since in here, na-substitute na natin yung 50 degrees Celsius, nakakuha na tayo ng temperature in Kelvin, so gagamitin natin siya. Sabi dito, find the mass at T is equal to 50 degrees Celsius using ideal gas law equation. So, hanapin natin yung mass, but since ideal gas law naman is PV in RT, so wala namang mass dito, pero pwede natin kunin yung mass by manipulating this equation. Okay, so we have, since sabi dito PV is constant, no, from the given pressure is constant, no, pressure is constant kasi di ba sa loob ng hot air balloon, okay, constant yung pressure diyan, no, alangan naman na nagbabago kasi constant naman yung air diyan, no, and at the same time yung volume niya is constant, alangan naman na nagbabago yung hot air balloons, hindi naman, di ba? So therefore from ideal gas law, since constant yung P at saka yung V, therefore, the left side is constant, okay, equals to nRT. So, since molecular mass is equals to mass over N, and solving for N, we have mass over molecular mass, then substitute natin dito sa ideal gas law na derive natin, ang mangyayari is constant, mass over molecular mass or molecular weight, multiplied by R at saka yung T. Okay, take note yung N dito is pinalitan lang natin ng M over MW. M over molecular weight or molecular mass. Okay? So therefore, since constant lang naman yung molecular mass natin, at the same time yung R natin is also constant, Okay, yan yung universal gas constant natin. So therefore, remaining is constant is equals to mass multiplied by temperature. So therefore, makakakuha ka na ng relation for mass and temperature, constant. Kagaya na sinabi ko, pag may constant ka dito, every phase, ibig sabihin yan is every phase, the multiplication of mass and temperature is constant. Kagaya ng dito, T1M1 is equals to T2M2, which is equals to constant. Okay, so manipulating that one, solving for mass at 323 Kelvin, so equals to mass STP. Take note here, yung mass 2 is pinalitan ko siya ng 323 kasi yung phase 2 is meron siyang temperature na 323 Kelvin. So kaya pinalitan ko siya, okay? So equal to mass STP multiplied by 273 over 273 Kelvin over 323 Kelvin. Then cancel out, then the result is 2.41 times 10 to the power of 3 kilogram. So therefore, okay, since the balloon will raise if its total mass, balloon, basket, and equipment and riders is less than the difference between the displaced air mass and heat air mass, so we have to take the difference. Then after we have to take the difference, yung ibig sabihin nun, yung difference na yun is yun yung makakaya niyang i-lift. Or kung yung difference na yun is maliit kaysa sa original mass, ibig sabihin nun hindi siya pwedeng lumutang. But since malaki siya, ibig sabihin pwede siyang mag-up no, or yung sinatawag natin na pumunta sa taas. Okay, so yun, ito yung final answer natin. So 440 kilogram.